Hi guys, we are on section 6.3. I need you to open up your textbooks please to 292. It's got the definitions for you of cross product and of the cross products property. We talked a little bit about cross products when we were trying to determine if two fractions were equal to each other. And basically the cross products on page 292 say that those are the product, meaning multiply, of if you have two ratios, you have a one numerator times the other denominator and vice versa. So for instance, if you have, I'll just do this with algebra, if you have two ratios, A over B and C over D, and if you tell me that those two ratios are equal to each other, then their cross products are multiplying this denominator times the numerator, B times C, and A times D. And the cross product property says if these guys are truly equal to each other, then their cross products are equal as well. So we're going to use this cross products property in these first couple examples to determine whether we really have a proportion. A proportion meaning that we can say one ratio is equal to another one. They have the same value on the number line. So let's see if 6 over 14 is really equal to 3 over 7 using the cross products. So 14 times 3, that's one cross product, and 6 times 7 is another one. And are those really equal to each other when we multiply them out? And actually they are. 42 is equal to 42. So these are a proportion. They are, in fact, equal to each other. If you look at 6 over 11 and 9 over 16, when we do the cross products, we get 11 times 9, which is 99, and we get 16 times 6, which is 96. These are not equal to each other, so we cannot set them up with an equal sign in the middle and say that they form a proportion. Easy enough, right? Okay, so basically we're going to work a few problems here to determine what X needs to be to actually make this a true statement. We're going to do the cross products property. And this is kind of cool because all your fractions go away. You multiply that guy times that guy, 18x, don't forget to write the 18 first, equals 42 times 3. And now we have to solve for x. So 18x equals, what's that, 126? Divide both sides by 18. You're solving for x. And x equals, and maybe you have to go over here and do it by hand. Let's see, 8 times, what would that be? 8 times 5, no. 8 times 7? 8 times 7 is 56, carrier 5, that's 12. Yep, x is equal to 7. So when x is 7, this becomes a true statement. Any other number for x, you cannot put an equal sign in between them. Let's work another one. Cross products, identify them. 10 times p equals 16 times 45. Okay, that's a little bit bigger number. I'm not going to take the time to do it by hand. I am going to grab a trusty calculator and get 10p is equal to, let's see, 720. Divide both sides by 10. Make sure that you're showing me all your steps and you're lining up these equal signs. P is equal to 72. So when P is 72, these two ratios actually do equal the same spot on the number line. All right, these get a little trickier. When you have something attached to the X, put parentheses around your term, because we are going to use our friend distribution when we're doing our cross products. So 48 times 15 is equal to 30 times parentheses x plus 9. And here's our distribution with our grouping symbol. So grab a calculator. 48 times 15 is 720. When we distribute the 30, we get 30x plus 270. Subtract 270 from both sides. And we get 30x is equal to, let's see, what's that? 6 would be 450. Divide by 30, I'm running out of room. And we get x is equal to, I think that's 15. 450 divided by 30 is 15. And obviously the way to check it is to plug 15 in for 9 and make sure that your cross products are equal. Let me do the number 6, and then I'm going to ask you to do number 7 and number 8 on your own. 20 times 13 minus x equals 35 times 28. Distribute. 20 times 13, well, 2 times 13 is 26, so add a 0, 260, minus 20x equals, and then 35 times 28 is 980. A little more arithmetic, subtract 260 from both sides, bring down the minus 20x, don't forget the negative sign, and that would be, let's see, 720. I have a lot of 720s on this worksheet. Divide by negative 20. Got to be real careful with your signs and your arithmetic. And when you divide 720 by 20, you get 36, and my quotient is negative 36. All of these can be proven by plugging x back in the original equation and seeing if your cross products are actually equal. So like I said, I want you guys to do number 7 and number 8 on your own. We'll talk about those in class. And let's look at number 9. Do we have a number 9? Okay, maybe you just have a 7 and 8. Very good. Let's look at a couple of these word problems, because this is where we're really going to spend the bulk of our time when you come back into class. So when you write proportions from word problems, it's very important that you set them up correctly. So basically, if we are using a proportion, we have got two rates equal to each other. So there's our shell. One fraction equal to the other fraction. We've got units in the numerators and units in the denominators. The units are going to be part of our problem. Write units. So what do we know? We know that the rate for this greeting card store is 39 cards in 2 hours. That's a rate. 39 cards in 2 hours. I've written my units for numerator and denominator. Now, because I started with the cards in the numerator with this one, I am going to have to put the cards in the numerator on this side and the hours on the other. Let's go look and see what they tell us. At this rate, how many birthday cards? You know you're looking for the number of cards. That's our X. Will they sell for the day? And they tell us that the store is open for 10 hours. So now we've set up our proportion. We've got cards and cards and hours and hours. Now we rewrite and drop the units so we can do our algebra. Use your cross products. 2x is equal to 39 times 10. 2x is equal to, that's 390. Divide in half. And we get x is equal to, if you take 390 and you divide it by 2, you get 195. So your answer is, and your answer needs to be written in a sentence. The answer is, you will sell 195 cards in 10 hours. This is the format. This is where I'm going to be looking for your answer. This is your work. This is your answer. Let's look at number 10. See if I've got the same thing. I have a different number 10 than you do. Your 10 is my number 9. Okay. So, in a batch of 120 manufactured parts, 3 are defective. At this rate, how many machine parts would be defective in a batch of 12,000? Your proportions start with your shell. Looks like this. What's the rate that they give us? These are the total parts, with 3 of them being bad. So we have 3 defective parts out of 120 total parts. These units are really, really important. So we're talking about all parts, so we need an adjective. We need defective parts and we need total parts. Numerator over here, defective parts, total parts. Let's go back and plug in what we're looking for. How many would be defective? That's this guy. If you had 12,000 total. Second step, write the proportion, dropping off your units. 3 over 120 is equal to X over 12,000. Cross multiply. 120X is equal to 3 times 12,000. 120X is equal to 36,000. Divide by 120. And you get X is equal to 36,000 divided by 120 is 300. Now you're going to answer the question. Your answer. So this is your work. Your answer needs to look like this. There will be 300 defective parts out of 12,000 total parts. Every bit of this needs to go in your answer. Woo, lost the 12,000. Okay, so let's see. Do you guys have a couple more? Yes, you have a few more. I want you to try these on your own. You can see we've got 11, 12, and 13. We just did 9 and 10 as a model. Okay, see you in class. Thanks for listening.